Thank you for coming tonight. This is the second meetup. The original intention was to run one in September and one in November, but George very kindly offered to do a presentation. So tonight, as you know, is multi-platform at HMRC. There's a few housekeeping bits. So the front door downstairs is locked. So when we leave, we're going to go down to minus two, and it's out the back. So
you come up by the Prince Albert. Right?
Cool. So if we want to have a drink afterwards, then we'll probably hit the Prince Albert and kind of take it from there. Just need to say a big thank you to Capgemini. They funded the pizzas and the beers, but also very importantly, Gemma and George basically organised that whole side of things. So big thank you to those for the pizzas. Tonight, the venue, big thank you to Luke, Hayes Digital. It's quite difficult when you set up new meetups because you have no idea where to go to get a venue. So local companies who are actually happy to kind of give us a space to do these kind of things is really important. These kind of events wouldn't happen, I don't think, if there wasn't local companies who are happy to do that. So if you are looking for a job, if you know anybody who's looking for a job, go see Luke and he'll sort you out. Over to you.
So, evening all. I'm going to talk to you about multi-platform at HMRC. My name's George and I'm a software engineer at Capgemini. We're going to talk through some of that. So who am I? What is multi-platform in general? Sort of like an end-to-end, not just Kotlin specific. So if you don't mind, I'm going to talk about other frameworks which can be controversial, but I'm going to talk to you about them anyway. Why did we choose Kotlin? How we used it at HMRC, under the hood, some of the outcomes, and some of the starters and how you could do it yourself at your own place of work if you wanted. Just quickly, as we alluded to, sponsored by Cap. Thank you to Gemma for organising the pizza. I'll say what she's got a face full of pizza just to embarrass her a little more. But yeah, I mean, I pretend I organised some of it, but apart from having the card that paid for it, I just gave it to Gemma and just said, please organise. So thank you for that. Yeah, thank you for the building and organising and all that kind of stuff. Just a bit of background on who Cap are. So we're a significantly sized consultancy of 220,000 people all around the world, in like most of Europe, North America, India, Australia, pretty much anywhere of size has an office. I think when I was on holiday to Morocco, I went past the Capgemini Morocco office just when I was out. I was like, who knew we had an office there? But yeah, we worked with all sorts of people. BBC was a project that I nearly got on, and they built iPlayer. So if you like the iPlayer, we built that bit. If you don't like iPlayer, we didn't build that bit. So who am I? So yeah, I've been working at Cap for 6 years, not always at HMRC in Worthing. I've worked all around the UK for various people, and yeah, so I've been at HMRC for 2 years and then 1 year in the mobile team, and that's where I've started to do some Kotlin. So before I was doing Scala, and as you can see, that's my view of Scala. I'm a big fan, possibly just because I've done it for a while. It's just I like to try something new. Kotlin's the sort of the cool kid in our team. We like to try something new, and then my hush sort of thing is Flutter, which if anyone has an interest in Flutter or Dart, you can talk to me afterwards, which can be controversial. So what is multi-platform in general? That is the definition. For anyone who doesn't know what multi-platform is, it's sort of pretty standard. Basically anything that can be run on more than one type of operating system or computer. So iOS, Android, JS, anything like that. So in the current space, these are your options. Give you a prize if can anyone name all five?
React,
Ionic,
Flutter, Kotlin, Xamarin.
There you go. I'll go home then.
Oh, what's the first one?
React Native, Ionic, Flutter, that's Kotlin.
Oh yeah.
And then Xamarin. So this is a comparison. So if you've got good reading glasses or good glasses, or you'll be able to read what that says. I'll send the slides out afterwards so you can dissect and read it. As you'll notice, this doesn't have Kotlin on for a very good reason. So these are all UI multi-platform libraries. So they support back-end logic and all that kind of stuff, but really they specialise in building components in UI and all that kind of stuff. So React, I have interesting views on because it's JavaScript, and you'll realise throughout the presentation I'm a big fan of JavaScript. But yeah, so I know places use React Native because they've got JavaScript developers and it's kind of the same kind of technology stack, so they can kind of progress. Xamarin, if you're into C# and you're a bit confused. Ionic, yeah, it's just HTML5, CSS, and then a bit of JavaScript. So again, has its perks. It's quite useful for simple apps, but if you have a complicated app, I wouldn't use it. Whereas Xamarin and React support more complicated apps. Like Airbnb did use React for a bit, and then decided against it and rolled back and went back to being native developers. And then there's my secret love, which is Flutter, which is starting to gain traction. It's very new compared to the others. The others have been around for quite a while. Flutter's built by Google, and yeah, it's gradually starting to build traction with companies like eBay and Spotify starting to build parts of their app, not necessarily their core app, but of the surrounding apps in Flutter. But they are all open source to a point. Some are paid for certain components, and yeah, they are mainly UI type frameworks. So what did we choose? Kotlin, which wasn't on that list. So there was lots of reasons we chose Kotlin, but mainly for some of these pros. So Kotlin multi-platform doesn't support UI really at all. Kotlin as a whole does. You can use things like TornadoFX to build Java UI, so Java FX, but it's called TornadoFX because Kotlin like to rename everything. But for multi-platform, it doesn't support UI really at all. It's mainly designed for all of your business logic to be consolidated into one core piece, and then you can build your presentation logic on top. So I'll talk about what we have at HMRC, but basically the native stuff is still in the core UI, and then everything underneath is multi-platform. So it supports pretty much anything you want to support. If you're outside of that stack, you're building something that is sort of outside of the use case, really. I mean, so anything on the JVM, so web stuff, anything with Spring, anything that runs on the JVM, that's fine. Android, JavaScript, because Kotlin compiles down to JS pretty easily. Then iOS, Linux, Windows, and Mac, just because the way Kotlin is written, it supports those as base. I don't know what the right word is, but basically it supports them because of the way that it compiles down to machine code and other such things. However, Kotlin does have some downfalls. They were things that caused Chris, I, and some of the members of the team to pull our hair out a little bit. So it's very experimental. It's still not in full public release. It's been in early access for 2 and a bit years, so it's relatively stable. It's just waiting for JetBrains to finally give the big rubber stamp and go, crack on, everyone can use it. The documentation, as I said to some of you guys outside, is pretty poor. It has documentation, not necessarily for the newest versions, which will be the biggest problem you'll ever suffer from. So you'll build it, and you go, oh, I've just got a problem, that bit doesn't compile. You'll Google it, and you'll find a question from a year ago, and you'll try it, it just won't compile. And you're like, this is exactly what I said, why does it not work? And it's because that was in version 0.15, and we're now in 0.40. And it's like, oh, we didn't update our documentation because we're still in experimental, haha, sucks to be you type thing. And oh, great, I'm so glad I've wasted a day of my life trying to get it to compile. As I mentioned, it's only for business logic. Wouldn't want to even dream of doing anything in the UI. Not in multi-platform land, but you could build your UI in Kotlin, but you wouldn't want to do it for your multi-platform. And something that trips us up is multi-platform libraries. So when you compile it down, I'll show you it shortly, but you have folders for each platform, so iOS, Android, then you have a common folder. So anything in the common folder has to be purely written in Kotlin. So any Java libraries you cannot use. So if it uses anything, so the R example was Joda time or local date time, you cannot use those because they require Java components. And as soon as it compiles down, it strips out anything to do with the JVM. And I spent quite a long time going, oh, it works fine on iOS, Android, that's great. Why does it not work on iOS? Oh, because it knows nothing about Joda time. Of course it doesn't, it's not written on the JVM. So there is other libraries that have been created called Clock with a K, which are purely written in Kotlin, so support these sort of things, but they are few and far between. So there's things like Ktor, which again is purely written in Kotlin for networking. but there is few other options. They're sort of being built as time goes on, and JetBrains building a lot of them. But initially, we are a bit scarce on some of the libraries. And even if there is a purely written Kotlin library, it doesn't necessarily mean it supports all of the platforms, because you can't just go, oh, it's written in pure Kotlin, I'll just compile it for all the platforms and that'll be fine, because it doesn't work like that. It has to be wired to map to the iOS things. So if, for example, Cater is a good example, it's not just a matter of, oh, we've just called the internet has responded with some stuff and here's the answer. It has to do it the iOS way, and then it has to do it the Android way, and then it has to do it the JS way, and then it has to do it the Windows way. So that's the bit that has to be wired under the hood, otherwise you've just got a library that doesn't do anything you need it to do. So, back to HMRC. As I said, I'm a big fan of JavaScript, so I'll let some of you read your way through those. So basically, the back end, or the logic, business logic behind the calculator was written in pure JS. It was about 1,600 lines of confusion and poor coding standards and everything else. But the long and short of it was, there was like no testing on it, there was nothing. It was basically just this big abomination of JS code, and everything was stored as a string, all the numbers were a string, everything that the user entered was stored in a big JSON string thing, and I'm sure the person who wrote it was very proud with it, but yeah, if I ever find them, I will beat them in the head, I think. So upgrading this last year took us 2 months, just to update for new tax year. So all we had to add in was the new tax bands and the new basic tax code, which is 1250L for this year, and just the standard tax codes. It took us 2 months, because every time we changed something, we thought, oh, that'll be the right place to change it. And then we put it in the app, because that was the only way we had to test it, which was putting it into the Android app or the iOS app. And then our poor QA would go through her spreadsheet and type in the numbers, and the number would come out and it would go, oh, that doesn't match anymore. You haven't even changed that one. How have you possibly broken something you haven't changed? And the answer was, we have no idea. So you basically roll back your change and you try again, and you sort of systematically you go, oh, this is ridiculous, why am I wasting my time? And it mainly boiled to the fact, we had no tests running against this JS. It was just a static piece of JS that we saved in GitHub. We had no pipelines or any Jenkins or anything running against it. I hoped when I joined the team it was written in Scala JS, which is basically you write it in Scala and it compiles into JS, and it looks awful. It's like 6,000 lines get produced, but at least it's testable and it's reproducible and it's kind of thing. This was just pure JS written by some guy in a dark room somewhere, I'm convinced, one day. And yeah, that's kind of my attitude to most of the thing. So, for a bit of context, so I hope everyone's got the HMRC app installed, but just in case you haven't, this is what the existing UI looks like. So it recently went under a sort of a facelift or a sort of improvement. So it actually looks vaguely nice. It's very accessible because we have an accessibility person in our team who's basically a QA, but she's dedicated to improving accessibility. So if you're partially sighted or struggle to use phones and you need large text and all that kind of stuff, it supports all of that. So yeah, for context, these are the fields that the user will provide. We can pre-populate things like tax code because we know your tax code because we are the tax authority. Well, we know the tax code we think you should be on. As you know, if you've ever rung HMRC, it's not always the right tax code, that's the one that we think it is. So you can enter your wage per year, month. Coming soon is 4 weeks if you're paid on a 4 weekly basis rather than a month. Per week and per hour. Obviously your state age, because that impacts your national insurance. And then your tax code. You'll be surprised writing some of this, you become an expert in tax codes because you have to know all the maths. So this is what the outcome is. So you get this nice snazzy circle with your breakdown of what tax is paid, including national insurance and the salary that you will bring home at the end of the month. And then that can be broken down by yearly, monthly, weekly, and soon to be 4 weekly as 4 weekly as well. And then that's your breakdown. So the reason I show you all of that is because that's all of the stuff. This is the stuff I needed to return basically out of the library, and the other stuff was the stuff that was coming in. So how all of this was coming out of that JS is one of life's great mysteries that I would love to know, but I'll never know. And yeah, so most of that was the problem. So every time we made a change, one of those rows would just disappear because it wasn't being parsed properly. So the solution is, for the people, tax calculator with a K. That's kind of it. It is. So it's open source, so anyone can go have a nose. Tax calculator is on the HMRC organisation. It's perfectly public available. You can even use it in your own app if you wanted. It's all hosted on Bintray and other things like that, which I'll get to later. But the long short of it is, you call it in your code much like a standard library. You just import it normally. You don't have to do any fancy couplings. Once it's been compiled, you just treat it like a library you would in iOS. You would treat it like a library you'd use on the JVM, so Kotlin, Java, Scala, whatever, it doesn't care, as long as it's compiled down. And then we have optional fields and things like that, so you can adjust what you put in and what you get out. I have got an example actually of what the output looks like, but those kind of the fields you'll get. So you'll get your wages, your tax breakdown. That was one of our big challenges, was working out how to produce what you get at the end of the breakdown per band, because that was where the confusion was. And we realised that actually, and this isn't a brag, we are the only tax calculator that is correct on the internet. Which you'd hope so, being an HMRC, but you'd be surprised how complicated it is. We found out our old tax calculator is wrong. It does say in big letters, this is only an estimate. So that's our get out of jail free card. We go, oh, it's only an estimate, so if it's out by a few pounds, tough, who cares type thing. But yeah, we had our BA spent days and days and days trawling the internet for calculators that were wrong, and then basically wrote his own Excel from scratch because it was just painful. What you'll find is if you think your tax-free is £12,500, you would be wrong. It's actually £12,509. Who knew that HMRC give you an extra £9? So the solution as a whole is now very testable. 98% coverage, branch coverage of 94%. It runs on a CI, it's very maintainable, and there's basically just one file you update every tax year with your new tax codes and your new bands, and that's all you need to touch. You don't need to worry about rewriting 500 lines of JS. So the good news is I discovered extension functions when I was writing this. We have at HMRC, we have a little Kotlin club, all with lots of K's in it, Kotlin and then club with a capital K. And Joe, who's not here, showed me extension functions, and basically I'm about to show you that pretty much the whole calculator is an extension function under the hood. So that's the first one. So basically lots of this is string to an object, because we had a real problem where obviously they're just chucking in 1250L or S1250L if you're Scottish, or C1250L if you're Welsh. And we had no way of identifying them. It was just a bit of mad magic in the middle trying to work it out. So I'm assuming people have seen extension functions before. Yes, no, yeah, that's fine. So basically we just go through it and then we just map and then work out using whens what you are. What I'll do is I'll show you. That is what it is on a slightly higher level. So this is how we take a string and convert it into a tax code. So everything at the end, there is an object for each tax code, so a B1, a B2, every D1, D2, every permutation of tax code has an object in the code, and then you can map them across, and each one has its own properties, and from there you can just apply all the rules of the tax code and it will just spew out the number at the end. As you notice, there are some where you don't have a country, so things like NT, so you pay no tax. You're very lucky. But so you don't have a country, there's no country discrimination for that. This is an example of what I mean by everything has a tax code at the end. So if you've got to the point where it's matching to an English tax code, you get BR, D0, D1, and then finally, I will bore you with two more extension functions. I think this is the last one. This is the slightly more complicated bit using weird regex that we have to do to match the remaining tax codes, the less obvious ones, or the more flexible ones, so the ones that have a number range at the beginning, and then a collection of letters, and then you start to find all sorts of tax codes you never knew existed. Like, if you're an emergency tax code, some of this is just an education at HMRC, but not necessarily to Kotlin. If you're an emergency tax code and it has W1, M1, or X at the end, you're an emergency tax, and bring up HMRC ASAP. because you're probably paying the wrong tax. So, as I said, one of our biggest problems was we had no CI before. So at HMRC, for all of our Scala and Java, we use Jenkins. All runs in AWS land, and that's fine. But for this, you need it to run on a Apple machine, or have access to an Apple machine, because to compile the framework for iOS, it needs all of the binaries and the libraries that are available there. And for our mobile stuff, we use Bitrise for our sins, which has good days and bad days, but it's generally okay. So this is kind of our pipeline that we have. So it does standard things like build, unit test, coverage, and publishes that kind of stuff. Make sure that we haven't regressed. That was one of the big things we had, which is make sure we hadn't gone backwards and make sure that our test coverage was always sound. And then this is where it actually starts doing the interesting bit. So it builds your iOS framework. So for the guys who've ever done the iOS, just a framework, is it an application.framework or an app.framework? That just produces a jar that can be used anywhere. And then this is where we publish it. So for Android, we publish out to Bintray, because that's what HMRC uses for everything. You'll find any of our public public libraries on Bintray. So things like if you wanted to use Taxi, we have a library for that and other things. And then Chris has spent the last week or so working out how to host the framework, because Bintray doesn't support that kind of thing. Only wants to support Gradle and Maven and things like that. So he found a funky way of basically saving it into GitHub. So under release, if you go to the release tab, there will be a section with each release, and under each release there will be a .framework, which Carthage interacts with and then downloads into the project and just pulls it in, and then you just use it as a standard library. And that's what I mean when I say, so Java stuff, Android stuff and JVM stuff doesn't go into here, that goes into Bintray. It could be consolidated and put into here, but for the time being, that's where you pull in your .framework into your iOS project, and then you can just run from there. So the outcomes. So in the Android project, so our code base is just one big repo really, there's a few other minor ones, but the main core repo, the adding of the tax calc reduced the code lines by 3,800 lines and only added 400. I know some of those lines have moved into a different repo, but they're actually testable lines now, so there's some value to be had in iOS. It only added 189 and took out 1,200. So big improvements, and actually would have helped our test coverage as well, because there was a whole big block of 3,000 lines that couldn't be tested by any means really, except some UI tests. That's all we had. Running through the app, madly entering numbers into the dash, and then hitting go and going, oh, that's the number I expected, or bloody hell, what's that number? So, a quick talk about how you build your own. So, in JetBrains, there are a collection of, there's a wizard that is, what's the right word? Unreliable, confusing, misleading. I don't know what the right word is, but there are 3 options on there that, if you didn't read the documentation, as far as I'm concerned, do exactly the same thing. One says build for mobile, one says build for iOS and Android, and one says build for iOS and JVM. I'm pretty sure 2 of those are exactly the same, and I'm not sure what the third one does differently. So you can either do it yourself or use that library, but basically that's the magic line. If you add that line to the plugins in your Gradle, you are now multi-platform. The only few things you have to do is you have to tell it which platforms you want it to build for. So otherwise it will try and build for all of them and then just fail catastrophically. So for us, we only support JVM because we need to support our web and and Android, and then we'll have an iOS one which produces the framework. And this is the way that the project gets set up. So I will send you the link for the source code so you can look through it and find defects in my code and send me PRs and make my life hell if you so choose. But this is kind of how it gets split up. So you obviously have, for each target, you have a main and a test, main and a test, main and a test. For this project, 99.9% of the code is in main. It's just maths. Don't need anything platform specific for maths. Fortunately, iOS and Android support the same maths, so it's all good. So it's all in there, and the only things we put into iOS main was around exception handling because there's some special exceptions that needed to be handled. As you'll notice, for multi-platform, they have the same plugin for JVM and iOS, slightly different for the source, for the common, because that's the purely written in Kotlin one, whereas these two are not. They're written specifically for iOS and one for JVM. And then that's the clock library I was talking about that we have to use, because I was going to use our tax year repo, but that has so much Java in it. That's what caused the problem. So simply put, this is what it will look like. So if you run it, obviously these are run in their own folders. So in the JVM main folder, there's a package, and then there's a file called sample.kt, and that same file has to be replicated in all of the platforms. Because if you, say for example, missed out iOS, the compiler would go, I don't know what to do in iOS, I can't compile. So you have to make sure you have one in each, and I'll show you the pattern you have to have. Is that the next slide? Or have I jumped ahead? Oh no, this is the slide, sorry. So, I thought it was another slide. So, what you'll notice here is we have expect. So the way that it works is it's like a handshake. So you have, basically in your common folder, if you need to have platform-specific stuff, which is rare, but if you do, you would say, I expect to have this method. And it says, I expect to have this object of platform, and it has a property of name. And if I was just to run it with just that, it would go, I don't know what you mean, I have no implementation of these objects, please help. So in JVM, you then do an actual, and this is the handshake, so if something that expects needs to have an actual, and at this point you can set the actual of string to JVM, and then exactly the same for iOS. And when you call platform.name in your platform, so in iOS or Android, it will say hello from JVM or hello from iOS. Obviously, it's a bit more complicated than that if you build like massive solutions, but in essence, everything needs a handshake and everything needs an implementation. So that's how you do it across the board. That's it from me. Any questions? And if you want to tweet me, LinkedIn me, get me, that's me. If you want any questions about that or anything else, that's me.
So were the trade-offs worth it ultimately then? Because obviously the end solution is really elegant and testable and things like that. Was the pain that you went through for it not being?
So to write the whole library took me a month, probably end to end, which it's just me, because I took it on as a sort of I'm between projects, a bit bored type thing. I want to try something new. I kind of took it upon myself and just, I think one evening I decided to start writing, and then I was like, I could just do this during the day, so I just sort of created myself a ticket and off I went. And so in the long term it is, because before, if there was an error, you just said, threw an exception in the JS and just said, there was an error. Whereas now we have specific errors, so we have things like, invalid tax code, invalid year, pay period combination, so it helps the user a lot more as well. So even though the user doesn't see like a new UI, they get some better error handling, whereas before it was just, there was an error, we can't help you really, try again. So the trade-offs long term are going to be good, and I did test how long it would take me to add a new tax year in it. It's like a couple of days. So it's just adding some lines, a couple of loose tests to cover the new tax year number, and then off you go. Cool. That's me. So any other questions? But you're welcome to grab me afterwards if you don't want to ask me a question here as well. So.
Awesome.
Cool.
Thank you.